Hi, now I will talk about the SVM assignment solution. So SVM means support vector machine. SVM means support vector machine, and the problem here is SVM is used for many numerical predictive analytics purposes. So for this, the problem is the pattern recognition, and among the pattern recognition, most of the important one is handwritten digit recognition. So here in this case, we have a image of a digit which is written by a digital device such as scanner, tablet, or mobile phone, and our goal is to develop a model which can correctly identify the digit, that is 0 to 9, written in an image. So we need to develop a model which will identify whether the digit is written as 0, 1, 2, or 3, like that up till 9. Okay. So for this, our objective becomes developing a model which can classify the handwritten digits based on the pixel values which is given as the features. So initially we have a dataset which is called as the MNIST dataset, which contains a large database of handwritten figures. Okay. So this dataset contains about 60,000 rows. Okay, and it contains about 785 columns. So the first column of the dataset, it represents the digit, and the others represent the value in pixels. So 28 into 28, 784. Those 784 columns represent the value in pixel for that digit. So what happens is, as it is a huge data set of 60,000 values, and SVM is a time consuming process as it depends on the RAM speed, so we will proceed the analysis with 10,000 data. We will take less part of the data. So initially we have to start the analysis in R, and for this we need to install libraries like reader, dyplr, caret, ggplot, kernlab, gridextra. These things are needed for our SVM analysis. Then what happened, we load the test data and the trend data in our test and trend data sets respectively. After that, we reduce the size of the training data to 2000, because without that this SVM analysis becomes very difficult. So we reduce the sample size to 2000. So out of that 2000, we created an SVM with a validation size of 30% of the data, and the rest 70% data is training data. So training sample consists of 70% of the data which we choose, and and validation sample consists of 30% of the data. For the test sample, we kept all the data as 10,000, whatever full data we kept, because that is not needed for our SVM calculation. For our SVM model creation, it is only required for training. It is only required for testing. So it is not much time consuming to do the testing on a huge data set. So with our with our training data set at 2000, 70% of the data we kept for training, and 30% of the data we kept for validation of the model creation. As we told that in SVM there are three stages. Initially is training, then validation, and then testing. So initially for that, this is the data collection part. Now it comes to the EDA. For EDA, we just checked in for few top rows to understand the structure of the data, and then we checked about the columns of the data, and as the column names are fairly useless here, so for the first column only we create the name as label, because it denotes the digit which is represented by the pixel values given in later columns. So again we checked for the negative values in this data. Negative pixel value is meaningless, so in this case we found there is no negative value, and so means the data is fairly correct from negative value point of view. Then we checked for missing values, and we find that there are no missing values also in the training and the test data set. Next, for our analysis, we plot some data sets using for the training data set we plot some digits using a grid. Okay, so the grid actually gives the value of the digit, and as per the data set what it represents. So from that exploratory analysis for a few digits we found that for the first 28 rows and columns we found that the digits are fairly accurate. So this model, the data whatever is given, is fairly accurate in denoting the digits as per given in pixels. Next we created some analysis about the intensity of each digit. So from where we find that the intensity of 2 is the least, whereas other digits have fairly high intensity and all are nearly same. Okay, so the average intensity is minimum for 2, and for other digits it is almost same. Next, for each of the digits for 1, 2, 0, for 0 up till 1, 2, 3, 4, 5, 6, 7, 8, 9, we plotted the histograms, the intensity histograms, taking bin wide, and there is not something much we can understand from it, but anyway we just we just want to validate the histograms, the characters and the plot between the characters for the training data and for the labels. Okay, so almost it shows that they have a regular type of pattern. There is not much to be judged from the intensity. Some have a bit low intensity, some have quite high intensity as such. So next is the exploratory analysis, from where we didn't get much insights, so we proceeded to the model validation. So here for model validation we are using the SVM or support vector machine. So initially that intensity column we removed from our analysis, and we created first the SVM using a linear kernel. So for a model linear we created with a KSVM function and using the training dataset, and the kernel is vanilla dot, so which represents the plain linear kernel. So we use this model for evaluation on the test dataset, and on the test dataset, and we validated the confusion matrix. Okay, so from this creation of the confusion matrix, we came to know that the value of accuracy is less than 90%. So actually this model, though it's quite good, but it is not good enough for our purpose. So next time we started using RBF kernel. So again we created the next model using data as the training data and scale as false, and this time kernel is RBF dot. For the RBF kernel we created the confusion matrix and found that the accuracy has increased a bit to 93%, which is quite good for our purpose. So next comes in this case is the hyperparameter tuning and the cross validation. For hyperparameter tuning, we used a function as train control, and we used our method as CV, which is cross validation, and number of folds in CV as 5. So we have set the seed to 7, and we are expand grid functions we are using to take the set of hyperparameters which we shall pass to our model. So set.seed as 7, and grid is expand.grid sigma from hyperparameter value for sigma is from 0.015 to 0.05, and for the C as from 0.1 to 2. So using these hyperparameters models, we are fitting the SVM on the train dataset, and we are using the method as SVM radial, metric as metric, and tune grid as grid, and TR control as train control. So with that, the final model which we created from the fit.svm, we found that the optimum value of gamma is 0.05 and the cost is 0.1, and the kernel we used is RBF dot. So from the final model, we used the KSVM on the label with gamma as 0.05, cost as 0.1, and kernel as RBF dot, and we got the final model. So we used the final model to predict on the MNIST test dataset. So finally we created the confusion matrix which showed that the value of the hyperparameter goes up till 95%. So actually in this case, if we have more processing power and we used the whole dataset, so we would have got the accuracy percentages close to 98% for this case. So in this model we can say that using SVM we are able to predict the handwritten digits using pixel values very accurately. And as we have used a smaller part of the dataset, so accuracy is less. On increasing the number of data rows in the training dataset, we can have increased accuracies up till more than almost to 99%. Thanks.